Welcome back to First Take Math. This time we're going to look at some examples that are a little more involved. Again, we're solving multi-step equations. The way I like to solve these problems, again, is we have to simplify each side. And one of the concepts behind simplifying is to remove the parentheses out of the problem. So notice how this side here has parentheses in it. I'm allowed to remove those parentheses by using what we call the distributive property. So a lot of times I use like the rectangular model to do this. So the negative is on one edge, the x and the 4 are on the other edge. A lot of people don't like that negative dangling by itself, so if you want, you can put like a -1 there. But remember, a negative just means to flip the sign. It means to take the opposite. So you really don't need that 1 there. Just remember that this just means to take the opposite of an x. Well, the opposite of an x would be a negative x, and the opposite of a 4 would be a -4. So in our problem, the left side is fine. -8 can't really be changed, but this here basically means to take the opposite of both pieces. So it's going to be a -x and a -4. And that's what my box tells me to put down. It's a -x and a -4. At this point, we're really close to getting x by itself. We've still got to get rid of this -4. To get rid of the -4, we use the zero pair of adding the 4 to both sides. A -8 and a +4 is going to give me a -4, and we have then the opposite of x. So if we look at this problem now, the opposite of what number gives me -4? Well, if I have a 4 there, the opposite of 4 would be a -4. If you want, you can then just, if you still need to have that -1 there, you can put that -1 there. And since this is multiplication, we also could go backwards and use division. A lot of people like that concreteness of a -1 there. So if I then go ahead and find x, this would be a -4 divided by -1, which in turn would give me a 4 as a solution. So if we check that out, if you put a 4 in, 4 plus 4 is 8, and the opposite of 8 is a -8. That does check out. Looking at example 6, we have 12 times the expression -4 times the quantity -6x minus 3. Again, to make this problem work a little bit more easily, one of the strategies is to remove the parentheses out of the problem. So if I want, I can use the distributive property to get those parentheses out of the way. So a lot of times we can use the rectangular model to use distributive property with. So the -4 is one edge, the -6x, and the -3 is the other edge. And we know that a negative times a negative is a positive, so that's going to be a 24x. And then a negative times a negative again is going to be a positive. That would be a +12. So when I look at this problem, I can change it to 12 equals then 24x plus 12. Now again, we're back to just this two-step equation. I can get rid of the 12 over here by using the zero pair. I'm trying to get x by itself. So always focus on the numbers by the x. I get a 0 then equals 24x, and those are done. Then if you look at the problem, I usually can see the location okay. 24 times what number is going to give me 0? Well, if you're multiplying, the only way to get 0 is you have to have a 0 in the problem. So x would have to equal a 0. If you can't see that, remember this is multiplication, and we can always go back towards that using division. We can divide. And if we like to use our calculators, x would equal then 0 divided by 24, and our calculators would indeed give us our 0 for that. And if we check that out, substitute 0 in, this piece would turn to 0, which leaves me a -4 times a -3, and a -4 times a -3 would be a +12. So hopefully this will help you work examples that involve the distributive property.